This is section 14.4, which is double angle identities. The book also actually has half angle identities, but we aren't going to deal with those at all in this class. We'll leave that for pre-calc. If you have a sine of 2 theta or a cosine of 2 theta or a tangent of 2 theta, that means you're taking your theta, your angle, and doubling it whenever you plug something in. And so solving problems that have a cosine 2 theta and regular cosines or sines can't actually be done unless we play with some identities. So there's a lot of options, particularly with cosine. Cosine has 3 different options you can work with whenever you're solving. So right now I can't solve cosine 2 theta plus cosine theta the way that it's written. But if I can write everything in terms of cosines, then I can solve it. So using this identity here won't be very helpful because it gives me a sine. And using this identity here won't be very helpful because it gives me a sine. So I want to use this identity here because that puts everything in terms of cosines. So this cosine 2 theta is going to turn into a 2 cosine squared theta minus 1 plus cosine theta. And this is now in its quadratic form. I'm going to rewrite it just a little bit. 2 cosine squared theta plus cosine theta minus 1 equals 0, and that can factor. You can also use the quadratic formula if you would like to. So here's 2 cosine theta, and here's cosine theta. And I'm going to do 1 and a 1. So I want two things that multiply to -1 and add up to 1, knowing that there's this 2 here in front. So I think I want to make this one positive and this one negative. Well, now I just solve this, so I know that 2 cosine theta minus 1 equals 0, and that cosine theta plus 1 equals 0. And that gives me cosine theta equals a half when I add 1 and divide by 2. And I think where on the unit circle does cosine theta equal a half? What's the x value? The x value is a half at 60 degrees. So theta is going to be 60 degrees, and I find its reference angle over here, which would be 120 degrees. And then where does cosine theta equal -1? Well, cosine theta equals -1 way over here, and that's at 180 degrees. Since this didn't clarify if I was doing degrees or radians, I put it in degrees. Since it's not asking for a certain range, it's not saying something like 0 less than 180, less than 0 less than theta less than 180, something like that. Since that's not happening, instead, I'm going to just list every possible solution. So I have to add a 360K to all of these that accounts for every possible revolution of the circle that can get me my solutions. If you can't figure that out in a unit circle, that's fine. You can always just do a sine or cosine inverse. Make sure your calculator is in degrees in this case. So if I do a cosine inverse of a half, I get 60 degrees. And if I wanted to check, I can now check this on my calculator. I can do the cosine of 2 times theta, and I'll plug in, let's say I'll plug in this 120 just to check. I'll plug in 120. So 2 times the cosine of 2 times 120 plus the cosine of 120 should hopefully come out to 0. And it doesn't. Why on earth not? Let me try 60. That one's okay. And I think my 180 is okay, so why isn't 120 working? Duh. 120 is not working because your teacher's a moron. We're doing cosine. And cosine is positive here, but also here. So this angle has to be 60 degrees. So I didn't want a 120. I wanted a 300. We're doing the cosine values. Cosine is x, so I did grab the x coordinates, not these ones. Hopefully you found that mistake the first time around. Okay, next problem. I've got a 2 sine theta equals sine 2 theta. Now these are different problems. This is 2 times the sine of theta. This is taking a theta and doubling it and then finding the sine of that. So those are 2 separate things. I want them to be equal to each other. Well, I can take sine 2 theta and rewrite it as 2 sine theta cosine theta, so I get this. And you might look at this and be like, well, don't I still have a sine and a cosine? Can't I still not solve this? Since right now there's no addition anywhere, this is going to be able to factor pretty nicely. I'll get everything on one side of the equation and factor out a 2 sine theta. And that gives me this. Well, now this is all equal to 0, so equal to 0 here and equal to 0 here, because I subtracted the 2 cosine from both sides. This is now factored and solved, so I can solve it. 2 sine theta equals 0, and 1 minus cosine theta equals 0. Well, if 2 sine theta equals 0, then I really want sine theta to equal 0, which means that I want theta to be, the sine value is the y value, and the y value is 0 here and here, so 0 and 180. I also want 1 minus cosine theta to be 0, which means that I want cosine theta to be 1, and the cosine value is 1 at 0. So my solutions are actually 0, 180, and 0 plus 360k. And in this case, that's the same as doing just 180k. This will go 0, 180, 360, 540, 720, and this covers that. So my answer is just theta equals 180k. The key to that problem was recognizing that even though we still had a sine and cosine, we could factor a sine out of those two terms, and factoring is how you're going to get through a lot of solving problems. 2 cosine theta plus 3 cosine of 2 theta plus 3 cosine theta equals 1. Well, look at this for a second and see which of these 3 identities you're going to want to work with. Since this has a cosine in it, I want this to have a cosine in it and not a sine anywhere. So I think I'm going to grab that second one. I'm actually not sure how this works, so we'll find out. So it goes 2 cosine squared theta minus 1 plus 3 cosine theta equals 1. And hopefully this also factors kind of nicely. 2 cosine squared theta plus 3 cosine theta minus 2 equals 0. And then I'm going to think about factoring this. 2x squared plus 3x minus 2. Well, that factors into a 2x, and an x, and a 2, and a 1, and a plus and a minus. So it's going to be, instead of 2x minus 1, 2 cosine minus 1, and then cosine plus 1. That's all equal to 0. So I want the cosine of theta, well, 2 cosine theta minus 1 to equal 0. So cosine theta equals a half, and I feel like we just did this. This happens at 60 and 300. And I want cosine to equal -1, which means that theta is going to be 180. And that's also going to be plus 360k. Is that the same problem we just did? I don't think so. No, similar but different. Same idea. Finally, sine squared plus cosine 2 theta equals cosine theta. I need to take my cosine 2 theta and somehow change it. And the question becomes, which option do I pick? At this point, I really don't know, so I just sort of try and plan ahead a little bit. I think if I grab this option here, I'll have 2 sine squareds, and those will cancel. I'll end up doing a sine squared minus a sine squared, and those end up canceling each other, and that's really nice. So I'll try that. So this becomes sine squared theta plus cosine squared theta minus sine squared theta, and that's equal to cosine theta. I also could have seen that this becomes a 1, sine squared plus cosine squared is 1, and then 1 minus sine squared becomes cosine squared, so there's other ways to make that work out. But right now these two things cancel, and I'm left with cosine squared theta equals cosine theta. Now here you might be tempted to do the following, and the following is not allowed. Don't divide both sides by cosine theta. You can't do that because that ends up killing some of your solutions. You end up with this, cosine theta equals 1, which means that theta must be 0. And that's correct, 0 will solve this equation, but it's not the only solution. There's other solutions that happen, and when you divide by cosine theta, you end up getting rid of some of those solutions. You should never divide by a variable in such a way that the variables get canceled somewhere. When that happens, you're causing problems. So instead, I'm going to get everything on one side. And then, of course, I'm going to factor, because that's pretty much all we do anymore. Now my solutions are cosine theta equals 0 and cosine theta minus 1 equals 0. Well, the cosine of theta equals 0 at 90 and 270. And cosine of theta equals 1 at 0. So my solutions are 0, 90, and 270. All of these plus 360k. I'll write that really lazy. I didn't do any tangent at all in this video. I might actually make a whole nother video that just does tangent with solving and double angles and all those things we could play with, but I just want to do sine and cosine for today, because the tough part is usually knowing which of these three to choose. With tangent, sometimes it's easier to take tangent of 2 theta and make it sine 2 theta over cosine 2 theta and do properties twice. I know that doesn't sound easier, but it often is, because 1 minus tan squared and tan on top can cause some problems. And there you go.